Hello, 10th graders! This is your School in the Air program, welcoming you to Mathematics 10. We are glad to be with you in this new normal journey of schooling through radio broadcast. I am your host, Teacher Marilyn B. Pipito from Tagum City National High School, and we would like to thank our radio partner, Hope Radio 107.1 DXHS, where we are airing our episodes for junior high school. Thank you for your generosity. How are you feeling now, dear students? I hope you are well and comfortable wherever you are at this time. I must ask you now to stay in a comfortable, well-ventilated and well-lit area where you can listen intently and take notes. Are you ready? That is great! Come and join us. Stay tuned and be a one-of-a-kind Math Talino student. Our topic for today will be distance and midpoint formula. This topic will be brought to us today by our teacher broadcaster, Mr. Danielo C. Mendoza, Master Teacher 2 of Tagum City National High School.
Hello there, students. Welcome to our class. I hope you are all safe and ready as we will explore another exciting lesson for today. Now that you are all settled in your homes, bring out your pens and secure your learning materials, specifically your Mathematics 10, Quarter 2, Module 7. Here are our learning objectives for today. At the end of this lesson, you are expected to find the distance between 2 points using the distance formula. Determine the coordinate of the midpoint using midpoint formula. And apply the distance and midpoint formula to solve the given problems. Before we start our lesson, let us have a bird's eye view of what is distance and midpoint formula all about. The distance formula comes with some uses in everyday life. It can be used as a strategy for easy navigation and distance estimation. For example, if you want to estimate the distance of 2 places on a map, simply get the coordinate of the 2 places and apply the formula. Or when a pilot wants to know the distance of an incoming plane and his plane, he can use the plane radar and find the coordinates of 2 planes and then apply the formula. In addition, the distance formula and midpoint formula are useful in geometry situations, where we want to find the distance between 2 points, or the point halfway between 2 points. As we go through this lesson, think of the important question: how do the distance formula and the midpoint formula facilitate in finding solutions and making wise decisions in real life? Now let us have a simple recall about the Pythagorean theorem, a prerequisite knowledge to understand distance and midpoint formula. Have you ever used the Pythagorean theorem before? If not, make sure to check out the Pythagorean theorem lesson. If you have, then you already know how to find the distance between 2 points. We usually think of the Pythagorean theorem only for a right triangle that's drawn, but you can also use it to find the distance between 2 points on a plane. Let's say you have to find the distance between the 2 points shown in the graph. If you use the grid lines to draw in lines down and across, we can form a right triangle. Now we have already a right triangle. By that right triangle, we can use the Pythagorean theorem to find the distance between A and B. The distance we want to find is the hypotenuse of the right triangle. And we just count the spaces to find the lengths of the legs. A equals 4, B equals 3, so therefore C equals 5. Aside from counting the spaces, you can find also the unknown value using Pythagorean formula. By substituting the value to the formula, it becomes C squared equals 4 squared plus 3 squared. Simplify, it becomes C squared equals 16 plus 9. Simplify further, becomes square root of 25. So the answer is C equals 5. Let's look at another example. Say, you have to find the distance between 2 points, 1, 2, and 6, 4. First, let's plot the points on a graph and draw in the line segment between the 2 points. We need to find the length of this segment. Next, we can use the grid lines to create a right triangle. The distance we want to find is the hypotenuse of the right triangle. And we can just count the spaces down and over to find the lengths of the legs. We can just plug these values into the Pythagorean theorem and solve for x. So A equals 5, B equals 2, So therefore, C equals square root of 29. Now let us have a short activity. Activity number 1. The length of one side of each triangle is unknown. Determine the length of each side. Use Pythagorean formula, where C squared equals E squared plus B squared. Based on the first given figure, E is equal to 3, B is equal to 4, C is unknown. You have 5 seconds to answer. The correct answer is C is equal to 5. Did you get it correctly? That's great. Number 2. Determine the length of the second figure. E is equal to 9, B is unknown. C is equal to 15. What is now the value of B? You have 5 seconds to answer. The correct answer is B is equal to 12. Did you get the correct answer? Good work! You are learning very fast. Remember, in finding the length of the unknown sides of a right triangle, we need to find the hypotenuse first, which is the longest side of a right angle triangle, and which is the side opposite the right angle. The length of the hypotenuse of a right triangle can be found using the Pythagorean theorem, which states that the square of the length of the hypotenuse equals the sum of the squares of the length of the other two sides. Now let us discuss distance formula and midpoint formula. Distance formula is an equation that can be used to find the distance between any pair of points on the coordinate plane. The distance between 2 points x sub 1, y sub 1 and x sub 2, y sub 2 is given by the formula d equals square root of quantity x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. The distance formula is derived from the Pythagorean theorem. To find the distance between 2 points, add the square of the difference of the abscissa to the square of the difference of the ordinates, and take the positive square root of the sum, where d is distance, x sub 1, y sub 1 is coordinate of the first point, x sub 2, y sub 2 coordinate of the second point. Now let us consider these examples. Example number 1. Find the distance between the points 1, 2, and 6, 14. Given x sub 1 equals 1, y sub 1 equals 2, x sub 2 equals 6, y sub 2 equals 14. How do we find the answer? Substitute the values to the distance formula. So then it will become d square root of quantity 6 minus 1 squared plus quantity 14 minus 2 squared. Then square root of 25 plus 144. Simplify further, it becomes d equals the square root of 169. So d equals 13 units. Were you able to follow? Nice going. Now let us have another example. Example number 2. A map showing the location of different municipalities and cities is drawn on a coordinate plane. Each unit on the coordinate plane is equivalent to 6 kilometers. Suppose the coordinate of Mabini City is 22 and Santa Lucia town is 68. What is the shortest distance between these two places? From the problem given, x sub 1 equals 2, y sub 1 equals 2, x sub 2 equals 6, y sub 2 equals 8. Substitute these values to the distance formula. It becomes d equals square root of quantity 6 minus 2 squared plus quantity 8 minus 2 squared. So it becomes square root of 16 plus 36. Simplify further, becomes square root of 52. So d equals 2 square root of 13 units, or approximately d equals 7.21 units. Since 1 unit on the coordinate plane is equivalent to 6 units, multiply the obtained value of d by 6 to get the distance between Santa Lucia town and Mabini City. So 7.21 times 6, the answer is approximately 43.26 kilometer. That's easy, right? Now let us discuss the midpoint formula. Midpoint formula is defined as the mathematical equation used to measure the halfway between data points. The midpoint aim of the segment joining x sub 1, y sub 1 and x sub 2, y sub 2 has the coordinate of aim equals quantity x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 is also divided by 2, where M is the midpoint, x sub 1, y sub 1 is coordinate of the first point, and x sub 2, y sub 2 coordinate of the second point. The graph shows the midpoint formula and coordinate of the first and second points. Now let us consider these examples. Example number 1. Find the coordinates of the midpoint of the segment whose endpoints are 1, 2, and 3, 4. To find the answer, given x sub 1 equals 1, y sub 1 equals 2, x sub 2 equals 3, and y sub 2 equals 4. Substitute to the formula, it becomes m equals quantity 1 plus 3 divided by 2, and 2 plus 4 divided by 2. Simplify, m becomes 4 over 2 and 6 over 2. Simplify further, so the answer is m is equal to 2, 3. Example number 2. The Lotto Mart is mapped on a coordinate grid, with the origin being at the main entrance. The chocolate bar is located at point -1 and 3, and the cake house is located at point 1 and 5. Where is the midpoint between the 2 points located? Substitute the values to the formula. It becomes m equals quantity -1 plus 1 divided by 2 and 3 plus 5 divided by 2. M becomes 0 over 2 and 8 over 2. Simplify, the answer is m equals 0 and 4. Now let us summarize what you have learned so far. The distance between 2 points x sub 1, y sub 1 and x sub 2, y sub 2 is given by the formula d equals square root of quantity x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. The midpoint m of the segment joining x sub 1, y sub 1 and x sub 2, y sub 2 has the coordinate of m equals quantity x sub 1 plus x sub 2 divided by 2 and y sub 1 plus y sub 2 is also divided by 2. At this point, please prepare your quiz notebook and your pen. Focus your attention and be ready for our assessment. I will only be asking 3 questions for this test. Are you ready? Let us begin. Number 1. Find the distance between points 8, 1 and 0, -5 on the coordinate plane. A, 10, B, 15, C, 20, D, 25. Number 1. Find the distance between points 8, 1 and 0, -5 on the coordinate plane. A, 10, B, 15, C, 20, D, 25. You have 5 seconds to answer. The answer is A, 10 units. So distance equals 10 units. Quiz number 2. What is the distance between the points C, -3, 4 and D, 3, 4? A, 5, B, 6, C, 8, D, 9. A, 5, B, 6, C, 8, D, 9. You have 5 seconds to answer. The answer is B, 6 units. So distance equals 6 units. Great thinking. You can follow the solutions provided. Number 3. Find the coordinates of the midpoint of the segment whose endpoints are -4, -6, and -4, 6. A, -2, 0. B, -4, 2. C, -4, 0. D, 0, -4. Again, find the coordinates of the midpoint of the segment whose endpoints are -4, -6, and -4, 6. A, -2, 0. B, -4, 2. C, -4, 0. D, 0, -4. You have 5 seconds to answer. The answer is C, which is m equals -4 and 0. You can follow the solutions given. For your assignment, please answer the Let Us Enhance activity on page 8 of your Mathematics 10, Quarter 2, Module 7. Kindly put your answer in your notebook for checking at the same time. Sit in the weekly home learning plan. That ends our lesson for today. Stay updated next week for another exciting lesson. Until next time, be healthy and God bless.
Thank you, Teacher Dan. That ends our lesson for today. For you to understand our topic further, you may do the exercises provided in your modules. You may also have an advanced study of your topics to prepare yourself for your next lesson. Remember that the key to mastering mathematics is constant and diligent practice. Remember that the key to mastering mathematics is constant and diligent practice. Please make sure to be with us next session here at the School on the Air program of the Department of Education. This has been your host, Teacher Madeline Pipito. Keep safe, everyone!
TV High, dito sa City High. Makisabay, matuto't maglakbay sa